Hello friends. Last time we stopped at the usage clause, and today we're going to continue with the usage clause from where we had stopped. Before starting the usage clause which is used in COBOL, let's know what are some basic terms such as nibble. Nibble is basically a colloquial term for 4 bits and generally used in packed decimal data. A byte consists of 8 bits and every character is stored in a byte. Half word is basically 2 bytes, which is nothing but 16 bits. And full word is 32 bits, which is nothing but 4 bytes. And we have double word, which is generally used for your floating point arithmetic, which consists of 8 bytes. Now, in the previous video, we saw a display statement, and display basically takes the is the default usage clause. The number of bytes required equals the size of the data item, whatever we have given in the pick clause. Now, that is what by default it is usages display. Now you can use usages binary, usages computational, usages com. All three mean the same thing. And usage is index. It will come to index at a later stage when we are dealing with arrays, that is using occurs clause. And usage is packed decimal is nothing but comp3, which is computational clause 3. So we'll try a few examples in our this one and see how it goes using the usage clause. Okay, for better understanding like how data is stored in a compact manner. So we'll just go online. Okay. We'll log into the TSO region. We'll go to the COBOL source library, what we've just created. Now this was the program which was created earlier, which we saw in our previous video. Now what I'll do is I'll copy the same program because I'll be changing only a few parameters wherever required. So I'll copy it into the same COBOL library. Here we go. That's it. We have a copy now. I've renamed it to prog002. So I'll be changing the program ID to prog002. Now since we are going to see all the usage and different kinds of pick clauses, I'll just have one and delete the rest. Delete this, and we just change typical this one. No need to assign any value. We can just ignore it. I'll show you later on by assigning values. Okay. Now this is a simple numeric data item. If you see 9 of 03. 9 of 03 stands for numeric, 3 bytes of numeric data. Now what I'll do, I'll change num1. Now I'll create a new variable num2. Now this is an unsigned, this is 9 of 03 is an unsigned numeric variable. Now let's make a signed numeric variable, which is S9 of 3. Okay. Now when you have sign, you can store a value something like -123. Sorry, -123 dot. Don't forget the dot after every this one. Okay. Now again in sign there is a variation. If you see here, sign is over punched on the last byte. If you look at when we will see how it is actually stored internally. For example, I can show you right away also. Let's just open an EPSEC file. See, star star C find. Okay, no problem. We'll come back to that because we can see using the display this one how it is. We'll have the value clause just for our for the usage for displaying and seeing it in the spool. Let's create another variable where we have sign. We'll have we'll try sign leading and sign trailing, so that it gives us an idea how actually data is stored when we give sign leading and sign trailing. So after the pick this one, insert sign leading separate. Okay. Likewise, oops, there's a space required here. As I told you, this S9 of 3, when without giving sign leading separate or sign trailing separate, then the sign is over punched on the last byte. Okay, I think there's a mistake in spelling. It is SEP. Yes, there you go. Because it's a keyword, it wasn't highlighted. So that's the best thing is if you forget some of the spellings, just do a high COB. All the COBOL keywords are highlighted. Likewise, now I'll have another number where I'm having S9 of 3 sign trailing separate. Now we'll have a trailing sign. Just we have, as we have a leading sign, we can store a trailing sign as well. Okay. Now let's do one thing. Let's increase the size so that it's easy for us to. Let's make it 5. It can hold a lesser value there. No issues with that. Now I'll have num5 pick 9 of S9 of 4 comp. As I told you, comp is used for your binary arithmetic and your especially when we are dealing with CICS COBOL programs. It's used to hold all the results, all these because as you are aware, most of your computer operates with binary digits. So most of your results, response, CICS response, everything is stored in binary. So hence this one usage is comp. You can just give comp or usage is comp. Both will work. Next, what else do we have? Again, you can give, if you want, you can give value 1 to 3. Okay, 6. We'll have S9 of 3. Now we'll give a packed decimal, that is comp3. Comp3 is for packed decimal, as I told you. We'll see how it is stored internally once we are putting it in an output file or seeing it in a spool. Okay. Next we have something known as comp1 and comp2. Comp1 and comp2 are generally used for your floating point arithmetic. These are these don't have any pick clause. Basically, comp1 is a single word floating point item, and comp2 is double word floating point item. So pick clause will not be specified. In comp1, the sign is contained in the first bit of the leftmost byte, and the exponent is contained in the remaining 7 bits of first byte. The last 3 bytes contain the mantissa. Similarly, COM2 is used for double word floating point item. Big clause should not be specified again for COM2. 7 bytes are used for mantissa, hence, and it's generally used for your high precision calculation. COMP3 is packed decimal. Generally, one digit takes half a byte. If you've seen a normal digit, it is a zone decimal where it occupies a complete byte. There is a zone portion of it and there is a digit part of it. Whereas in packed decimal, it just takes half a byte. That's a nibble. Okay, so when you want to calculate the size, if it's pick 9 of 5, you can just you can calculate the size as 5 plus 1 by 2, that will come down to 3 bytes. Now if it's 6, it will be 6 plus 1 by 2, it is basically, you can take it as 3.5, which you can round it off to 4 bytes. So it takes 4 bytes and a half a byte is lost. So generally what is recommended is COM3 to have odd number of digits. In case you have decimal, let there be an odd number of most significant bits, and decimal to be like 2. Let's say it's 9 of 5, v9 of 2. So 5 plus 2 is 7. It remains odd, plus even is always odd. So you can still, it reduces the wastage of the half byte there. So for a signed positive, you'll have C in the last byte, and last nibble, and D for signed negative, and F is unsigned positive, that we already are aware of. Okay, and comp and comp4 are almost the same. We have discussed comp. We've also seen, I'll just type in for comp1 and comp2 as well. Comp3 also we've discussed. Comp5 is basically similar to comp, but it can hold larger values. That is, it can hold up to the hexa equivalent of the big clause. For example, if I have 9 of 4 comp, maximum value it can hold is 9999. Basically 9999. Whereas if I have comp5, it can store a hexadecimal equivalent, which is nothing but 32767. That is, when you multiply with 16 power 0, 16 power 1, 16 power 2, and 16 power 3, you will get it around somewhere around 32767. Okay, now we'll just go for the comp1 and comp2. We have no pick clause. So it has a specified number of bytes. Okay, there is no pick clause. Please be very careful when you are using comp1 and comp2. Okay, we have seen comp. Now I'll also show some variations of comp when we are the size of the size of comp varies depending upon the pick size of this one. It is basically, let's say I'll name this as pick 1, and I'll name this as 2. Okay, now these are basically I'll just change the size to 4. Okay, I'll change the size to 9, and I'll have one more because I want to show you that in a given range of comp basically S9 of 1 to S9 of 4 occupies 2 bytes, S9 of 5 to S9 of 9 occupies 4 bytes, and S9 of 10 to S9 of 18 occupies 8 bytes. So I just wanted to show you the variations. This is the maximum limit what we can have. We can see how, I'll show you how we can see the length by giving by using the length of clause in the procedure division. Okay, we've covered all this one. Okay, now what we'll do is we'll just try to display, as well as we'll also display the length. Okay, clear. Now I'll delete these two, display num1. If you see here, these are the numbers what we have given. So what I'll do, I'll repeat it some 9 times. Okay, num2, I'll display num2, likewise num3, there you go, num3, num4, sorry, num4, yeah, num4, num5, give num5, num6, then again number 6, number 7, number 7, number 8, number 8. Okay, we've just number 5 only we have additional this one, so we'll delete these two. Okay, I'll just repeat num5 twice. This is 1, this is 2, this is 3, again this is 1, 2, 3. Okay, so we are done with it. We'll first just execute the display, and then we'll also come to the length of clause, which I'm going to show you how to find the length of a particular variable when you are not sure how much a comp or a comp3 field is going to occupy. So I'll just show the length of these fields. Okay, I'll cover everything because that will give you a complete clarity of how much each of these fields occupy, actual length occupied by these fields. Okay, so we just save it, just execute it, proc002. Let's go to our job lib where we have stored our compile JCL, sorry, copcom. This was for 002, and we just check our load libraries. Where have we created our load libraries? This is our load module, so we'll copy as is. Let's go. Yes, there you go. The com after it, proc002. Again, where's my this one? It's in COBOL 36 dot COBOL dot sourcelet. Okay. There you go. Last time I done the changes in view mode, so it wasn't saved. So now just made it in edit mode. So this is where our program is there. Just cross checking. Go back. Let's go to the. Let's submit this job. Now there you go. Submit it. Oh, access C12. Let's see what's the issue there. Maybe some dot or. To see value clause literal was not compatible for the data item. F10. Let's go to this error message. We're debugging it. It's good that we are getting errors for simple programs. Let's put this one for okay. So basically the problem is with comp1 and comp2 because it's a floating point. This one we cannot give like that. My mistake. So let's go to the comp1 and comp2 variables. Now if you see here, comp1 and comp2. I cannot give value as 1 2 3 because I told you it is basically mantissa and exponent, this one. So maybe you can give something like, plus 1 2, uh, rather plus 0.12 uh, e power 4, and this one we can give something like plus minus 0.12 e power minus 4, something like that. This should not, this should remove that error whatever was there earlier. Okay, we have just done this. We'll again go there and shift F9. We'll again submit it. There you go. Okay, so, so let's go to the job. We've just done this. Now we've just done compilation. We have just displayed different kinds of pick clauses, and we want to see how the output is displayed, and we also want to see the length of different kinds of pick clauses, how it's actually internally stored. Okay, so this was the compilation, this one. Now let's go one step back and again run this program. So last time it was prog001, no, prog002. Now this is our load module, everything looks fine. I've again come in view mode, so I'll just each time I'll come in. The only thing is some of the compiled JCLs I don't want to tamper with it, so that's the reason I prefer to come in view mode. But however, since we have a backup, I think it should not be an issue coming in it. So we'll submit this. Once we submit, we'll see in SDSF how it's going to look. Okay, so I'm going to the spool. Okay, so now this is how each one of them is displayed. See, if you see here, now let's also open the program simultaneously. Close this. Let's open the program. Now let's see from here. Okay, now this is S pick 9 of 5 1 2 3, so that is why it's an unsigned one, so zeros will be padded wherever required. So that is why you have 0 0 1 2 3. Now if you see here, this is a minus 123. If it is to see, I told you sign is over punched on the last byte. Minus 123 will correspond to L, because if you see here, let me just open a notepad to explain it. If I am having a 120 plus 120, it will be displayed as 1 2, open the brackets, something like this. If it's plus 121, it will be displayed as 1 2 A. Likewise 122, it will be displayed as 1 2 B. Likewise it will go on till this one, and finally plus 129 should be displayed as 1 2 A B C D E F G H I J I. Okay, 1 2 3 4 5 6 7 8 9, so it will be displayed as like this. Likewise minus 120 will be displayed as 1 2 close flower brackets. Minus 121 will be displayed as 1 2 J. Minus 123 122 will be displayed as JK, right? Next, JK, and minus 123 will be displayed as 12L. And if you see here, we've got as 12L. It is minus 23. Because sign is not stored separately, sign is overpunched on the last byte. Clear? Now we have num3. Okay, we'll go to num3. If you see here num3, now I'm storing sign as a separate byte. If you're seeing here, minus is stored separately, sign leading separate. Likewise, sign trailing separate. If you see here, this is the trailing sign, this is the leading sign. Okay. Now even if I have not given the length clause, you can figure out now. If you see, I've given num51 as S9 of 4 comp. Let's go back here. S9 of 4 comp. I told you it will take, it can store maximum of this one, and it takes totally 2 bytes. Likewise, this one 8, maximum 18. Okay. I'll show with the length this one, then it will be much more clearer for you. Num6, what have I stored? Shift F9. Num6 is basically comp3. I told you it will take 3 bytes, and it's not a display field. Comp3 is not a display field, so I'm just wondering how it's displaying. Shift F9. Okay. Shift F7. Okay, we'll just do one thing. There's a trick wherein I can move the spool output to a particular data set. Taken 6 dot sign dot out, create new one. Okay, I'm not going to give any, I'll just make it as FB and record length as 80, conventional one. Looks okay. So I'll go there. The same thing what we are seeing, we're going to see it in a psec file. Second dot sign dot out, right? Go there. Let's not go in browse mode. Let's go in edit mode. I'm just doing a hex on just to check why it's coming like that. Now this is quite strange because the value what is stored in comp3 is being displayed as a normal variable. If you see here, it is displaying as f0. This is the zone. This is the zone, and this is the decimal. If you see f0, f is the zone, 0 is the decimal, 0 comes here, 1 comes here. So for all numbers unsigned at this one, it will be stored as f. And if you actually see a comp variable 1 to 123 in a S9 of 3 variable, it will be stored something like this. 0 0, then 1 2 3. This is how it's, and here you'll have the sign over punched. So if you see, these are not displayed. Now when I am doing something, this one again, it will not display this character. If you see num6 at this point of this one, it's a non-displayable character. I'll just do an X off just to check. So it will not show you that character. That's how packed decimal is stored. I'll come back to this, why this is being displayed as 0 1 2 3. Let me check. Okay. Now each of this one, if you want to know the length of it, so what I'll do, shift, I'll repeat this entire bunch. I'll just write from here, right? Yeah, insert length. Okay, we're going to have length of for each of these. Just a couple of more. Once we're done with this, we can see the length of the, remember, it's not the length of the value clause, it is the length of the clause. So again, we have to insert, this is a special this one, so just be careful. Now again, insert length. Okay, so if you just come out of it, it will be automatically saved in edit mode. Let's go again back. First we need to compile it, so just do a show JCL in the spool itself, and submit it. Oh, it's got hanged. Maybe there's a glitch in this one. We'll do a disconnect and a quick connect. Let's see if it allows us. It is so. Taken 36. We'll go to the spool directly. Sorry. Just one. Proc 002. We'll compile it again. See if there are any unforeseen errors. The return code is 0. So we're good to go with the run JCL, which is taken 36 RR. We'll just submit it again. Okay, come out of it. See the display this one. Now along with the pick clause, it will also show the length of num1, which is 5 5. If you see here, sign leading separate and trailing separate, it occupies an additional byte for the sign. Now likewise, num51 is basically, what was it? It was comp S9 of 4 comp. I told you it occupies 2 bytes. There you go. And S9 of 5 S9 of 9 comp occupies 4 bytes. S9 of 5 to S9 of 9 occupies 4 bytes, and S9 of 10 to S9 of 18 comp occupies 8 bytes. If you see here, it is occupying 8 bytes. Likewise, num6 is a comp3 field. I told you it occupies 3 bytes. This is how it is, that is 5 plus 1 by 2. It is integer part of it. Num7 is comp1, which is occupying 4 bytes, single precision floating point and double precision floating point arithmetic. That is comp2, which occupies 8 bytes. Okay, so we're good to stop with this.